Okay. So now we go to the second chapter, amplitude modulation. Okay. So by the word amplitude here, what does it mean? We're going to vary. Okay. We're going to vary our carrier. Our carrier amplitude will change following our modulating signal. Okay. Don't worry if you don't understand. We will go it later. Again, amplitude modulation is changes in the amplitude of the carrier following the modulating signal. The modulating signal, the name for the other
Doktor,
name for it,
doktor sorry ganggu. Slide
huh?
tak gerak doktor.
Tak, memang tak gerak, saya tengah cakap.
Oh, okey. Baik, baik.
Okay,
Okey.
okay. So amplitude modulation is the amplitude is carrier of the amplitude is changes following our modulating signal. The other name for modulating signal is information signal, audio signal, message signal. Okay? Okay. So what is modulation? Message itself is a signal, and audio signal, for example, kita bercakap semua, these are signals. A signal transmission to format suitable for transmission through a chosen medium. Then involve another carrier. Okay. So carrier, for example, let's say if you want to make analogy, let's say you have a person, okay, he want to move to another direction, another destination, let's say point B, okay. So he will, for example, drive a car, okay, to the destination. So the car is the carrier, okay. Let's say the person want to walk himself all the way to destination B is okay if it's close distance. However, it's very long. Is it possible? For example, this person required to walk from Perlis to Singapore. It's not possible. It can take long time, and maybe he will exhausted or pengsan or whatever along the way. So that is analogy to the concept of modulation. So our message signal will be carried by a carrier to the destination. Okay, and normally our carrier is higher frequency. Let's say the message signal 10 kilohertz, for example. You can see carrier frequency is very much higher. For example, maybe 1 gigahertz. Or maybe this one is 10 to power of 2 frequency. And the carrier frequency can be 10 to the power of 5. You can see it's totally different. So FC is much higher than FM. Carrier frequency, message frequency, information frequency, audio frequency, modulating frequency, a lot of name. Okay. Modulation type, they are for our syllabus. Okay, for our syllabus, we limit for uh, sinusoid. Okay, just for your own, just to open up your minds. Actually, as you study in the signal system, there is a lot of signal shape and form. Okay, so however, in communication principle, we try to maintain cosine or sine. But you must remember the signal is many type. Even the carrier can be different signal type. Okay, uh, it can be challenging to answer communication principle if signal is integrated, but it's not wrong if we integrate because signal and communication is adik-beradik. Signal tu adik, communication abang dia. Okay, so principal subclass includes in AM, amplitude modulation, and angle modulation FMPM. For now, you don't have to understand this. This is chapter 3. Now this is chapter 2. So pulse modulation, the carrier is a pulse trend. This is mode that allow for digital communication. This one we learn in later chapter, if I'm not mistaken, chapter 4 or chapter 5. So don't worry as well. This one is just an eye opener, okay, for what is to come. So benefit of modulation. Modulation can shift the spectral content. Okay, by the word spectral means spectrum. By the word spectrum, it means spectrum means spectrum. Means it is frequency range. Okay. If we use the word spectrum, if we use the word waveform, waveform is T. Waveform is time domain. Okay. So this is waveform. So spectra is like this. Okay. Okay. Uh, Antenna only efficiently radiate and emit signal at chosen frequency. So low frequency, low antenna length, higher frequency, shorter. Okay. So don't worry. So let's say you have let's say the signal is C equals to F lambda. Okay. Let's say I forget for example only maybe you have two audio voice. Maybe you have 4K and then you have 40K hertz. So for antenna, for transmitter antenna to transmit antenna wirelessly, uh, the signals is actually the size of the antenna is lambda over 2. Okay, lambda over 2. If we want to transmit 4K of audio without modulation, the size of the antenna is lambda over 2. L equals to lambda over 2. Assuming the wave is move at the speed of light, lambda equals to C over F over 2. So C over 4K over 2 divided by 4K divided by 2. So if from this equation, your antenna that to transmit 4K will be um, 37,474 meter. So pernah tak tengok antena panjang ni? Mana ada kan? So 37 kilometer. Let's say 40K. Now you want to 40K pula. So the antenna will be 3747.4. So besar juga kan? So that's why it is not possible to transmit the signals at its own frequency. First, the antenna size will be larger. Second is that you will have many antenna of different size because you have several frequency. Contoh saya cakap 4 kHz sebab nanti saya cakap 5 kHz, lepas tu saya cakap 6 kHz. Takkan semua nak kena buat antena setiap frekuensi. So that's why we use modulation, okay, to reduce the size of the antenna transmitter because the FC is much higher than FM. That's why you semua tengok antena kecil je transmitter tak tinggi pun. And by using one carrier frequency, all of them, let's say 4 kilohertz, 40 kilohertz, 500 kilohertz, all of them will be based on one carrier frequency, satu je, one carrier frequency. Okay, so it's standardized. The antenna is deal with one carrier frequency only, and we don't need several antenna size and several numbers of antenna. Okay. So modulation permit the use of multiplexing. Multiplexing is combination of signals. Okay, we allow the signals to be sent simultaneously. Okay, by multiple user using same channel. So the concept of multiplexer maybe can be analogy from your previous degree subject. We call it digital electronics, multiplexer, decoder, encoder, and so on. Saya ajar juga digital electronic actually. Okay, so multiplexer. So analogy lah, but this one is communication multiplexing tak sama but analogy means we can transmit several information or several users using the same channel lah. Modulation can provide some control over noise and interference. Okay, this one we will go later. We will even compare lah amplitude modulation and FM modulation. FM is better at noise immunity. Means it's more immune to noise compared to AM. Okay. So for this chapter 2, the objective is to learn AM modulation and demodulation. AM modulation happen at transmitter side, like what I told in the chapter 1 earlier, and demodulation happen at the transmitter side. Mode, demode. And then we learn AM generation and detection. Okay. How we going to generate amplitude modulation signals and how we going to detect them at receiver side. So this one at transmitter side and this one at the receiver side. Okay. So some variants of AM signals, we have double sideband and carrier. So double sideband and carrier, FC, FC plus FM, FC minus FM. So you have double sideband and then a carrier. And then you have double sideband suppressed carrier. Now, this one is being suppressed. Okay. So this is double sideband suppressed carrier. You only submitting double sideband. And then single sideband suppressed carrier means you suppress the carrier and also you only have one of the sideband, means only this one, for example. So this one is uh, lower single sideband. Okay. So our information is containing in the sideband, not in the carrier. Carrier is contributing to majority of the power, but it contain no information. Okay, hope you get that. Information is in the sideband. We have two sideband. These two sideband carry identical information. So single sideband is better because we are saving, for example, in terms of information and bandwidth. Because single sideband contain just one information compared to double sideband containing duplicated of the same information. So if we have two, means it's going to consume more bandwidth. Okay, we have more bandwidth now. Okay, then the next is a vesicle sideband. So this one is single sideband and a carrier, and this one is single sideband suppressed carrier. Okay, single sideband suppressed carrier. Single sideband, you have one of them, and you have carrier. With one of the sideband is being removed, let's say upper sideband, so you have two, and then single sideband suppressed carrier. Now you have, sorry, yeah, okay, tak apalah, last lukisan tak berapa nak ikut scale. So single sideband suppressed carrier, you have one of the sideband removed and the carrier is removed. Okay, then you have vesicle sideband. This one is compromise between double sideband and single sideband. Later this one will be explained. Okay, so baseband is a range. Baseband communication. Baseband communication is communication where it use the information directly, didn't change. Means we didn't have carrier. For example, baseband communication, if I not mistaken, our telephone. Okay, not our handphone, our telephone is a baseband communication. Okay, so the communication that use uh, didn't use any modulation, okay, and then it's used as direct telephone. Okay, for handphone is modulation, of course. Okay, Baseband communication is a range of frequency signal to be transmitted, audio or video. Okay, so this one is baseband. Baseband is baseband communication, like I told you just now, without frequency shifting. Frequency shifting is what involved in the modulation. Okay, because it will be mixed with carrier frequency. So there is frequency shifting. Okay, so baseband communication significant power for whole range of frequency. Okay, not suitable for radio wave and satellite communication. Okay, satellite communication and radio microwave. All of them, both of them is wireless communication. Using modulation. Okay, carrier communication is using modulation. That's why we have here carrier communication. Okay, to shift the frequency, change the carrier signal characteristic either in amplitude, okay, amplitude modulation, or in frequency and phase modulation. Frequency and phase is angle modulation. Okay, angle modulation. So let's say we have analogy only 20 cos 2 pi f plus phi. Okay, angle modulation is can be frequency modulation as well because this is angle. Okay, this is frequency and this is phase. Okay, so angle modulation can be phase modulation PM or it can be frequency modulation. Together, whatever it changes, it is considered angle modulation because whether the phase is changed, frequency is changed, or both of them changed, the angle will be changed. Theta. Okay? Because theta is contributed by this component and this component of phase. Okay? So the double sideband, okay, double sideband full carrier means we are submitting double sideband with the carrier. So this one we consider the conventional name full AM. So when we talk about full AM, it's actually double sideband full carrier. So AM modulation is a fundamental modulation process in communication system. AM technology is not doesn't mean all. It's just that it has been using uh, in the communication device. Uh, Most of them is using frequency modulation. Okay, not AM. However, AM modulation understanding is fundamental in order to understanding in order to understand frequency modulation. That's why we still teach AM modulation. And AM modulation is not totally like all in all devices. Some signal processing or other applications still use amplitude modulation. Okay, so like I told in the previous slide, previously FC over FM much greater. Okay, the frequency of the carrier compared to the message frequency. So because we have modulation, okay, the circuit that will do that operation called modulator. Okay, so modulator is used to generate AM signals, AM, DSBFCT, okay, varying with time. So therefore shown in this block diagram. Okay, so this is your modulating signal. Okay, or the other name like I told you just now can be message, can be information signal. Okay, many names. And then if we go to the AM modulator where it is going to be mixed with a carrier frequency of FPC. And then for AM modulated signal, for DSBFC, the general equation is EC Vm cos omega c. So our carrier is actually EC. Okay, for example, EC cos omega ct. So EC is the amplitude, the maximum, the maximum magnitude, not the real amplitude, is the maximum because it's a cosine. So this is your EC. Similarly, for the Vm, for the modulating signal Vm, okay, you have Em as the maximum. Okay, so Vm equals to Em cos omega m t. This omega m is actually 2 pi f n. So similar to this concept, omega c equals to 2 pi fc if we expand them. So remember, this one is the standard form for AM DSBFC modulated signal equation. So amplitude of carrier, equation of message signal times cos omega c. Okay, so this one I have gone through just now. So we expand, then it will become like this: EC plus EM cos omega m t. Okay, then we introduce another concept of ratio. We call it modulation index. Modulation index is equal to ratio of the amplitude of the message signal, amplitude, the maximum, over EC. Okay, so by having this information, now you try to use this to simplify this equation. Okay, so EC plus EM taken into account, EM here rearrange is equal to MEC. Okay, so EC plus MEC, and then you factorize, then you have 1 plus M. So that's why from this one, you have this one. Okay, with the introduction of modulation index. From trigonometry identities, okay, cos A, cos B, trigonometry we give in the appendix, don't worry, it's just that you need to understand which one to use. Trigonometry is being given, okay. Uh, so after that, you expand this, okay, expand this cos A, cos B, EC cos omega ct plus M cos omega m t cos omega ct. So this is what the cos A, cos B just now. Okay. Then when you expand this, it will become these two. Okay. You see here, half half. So that's why you see the half here. Okay. And then if you notice, this is the resultance of increased frequency by plus omega c plus omega m. This one is resulted in decrease of frequency. That's why you have omega c minus omega m. When we uh when we try to visualize, okay, so you have omega c here, and then you have omega c increased by omega m, then you have omega c minus omega c minus by decreased by omega m. So this one is M EC over 2, and this one is EC. Okay, so this one is upper sideband, this one is lower sideband, this one is carrier, and this one is V voltage. Okay, this one is F hertz. Okay, so has been shown here. Okay, and then modulating band, if you want to include, it is very far, very far from there, omega m. So from the concept of modulation index, okay, we have several value of the index of modulation. Kejap saya nak kena letak reminder ni supaya apa kita berhenti 12.55. Ambil attendance dan sama dua. Saya kena letak reminder, takut saya syok mengajar ni. Syok mengajar tak sedar masa berlalu. Okay, so we have M, EM over EC. So the range of the valid M is 0 until 1. Okay, 0 until 1. We don't have negative. Okay. Okay. So this is a ratio of modulating signals over our carrier. So in case that they are the same amplitude, means 1 over 1, or 3 minus 3 divided by 3 is still 1. So we will have a full modulation. So this is what we call as full modulation. Okay, you can jot down your slide. This one is full modulation. This one where the EM is much higher than our carrier. Okay, sebab normally our, for example, normally our message is smaller than our carrier amplitude. Contoh, suara you bercakap mungkin 1 watt. Contoh, carrier tu sebenarnya mungkin 50 watt, lagi besar sebenarnya. So it's a bit awkward if the signal is audio is smaller lah. Okay, if it does happen, in terms of amplitude, EM over EC, if you have, it is EM is much higher than EC, then you have, this will be greater than 1. So then this will be happen. Okay, we call it over modulation. Okay, this one pula biasa-biasa, because this one is within the limit. Okay, just the normal modulation, but not full modulation. The full modulation is this, where our EM magnitude is equal to our EC magnitude. Then it's actually full modulation. So we have three conditions, three situations. Okay, so during over modulation, where the M is greater than 1, okay, so there is phase change in the modulation. So if you zoom this one up, if there is no phase change, there should be flow of just continuous. However, because of over modulation, there is phase change. Instead of this is like this, it will become like this. Okay, there is phase change. Okay, here the phase change is maybe uh, by lambda lah, because this one is 2 lambda complete. Okay, 2 pi, sorry, 2 pi, this one is pi. Okay, for example, so phase change. So what happened to the what the impact of having over modulation? There will be a data loss. Okay, modulation depth greater than 100 must be avoided. Okay, so it is only until full modulation for to avoid signal loss. Okay, so you have this just now. Okay, so having said that, then what is the value of zero? What is the value of zero? So if you refer to the equation, what things that make it zero means zero em over c. How can n can be zero? N can be zero if em is zero. So during this, if m is equals to zero, there is no signal being modulated. You only transmitted carrier only. Okay. Again, if m is equals to zero, there is no message signal being modulated. You only transmitted carrier. Okay. So this is the graph of the full modulation. Okay, where it's shown by where this one. Okay, we try to label them properly. Okay, so if you see, this is your audio signal or your message signal, for example. Then plus with your carrier. Carrier is maybe high frequency. Is actually high frequency. So let's say you have FM. Okay, of course this one is in terms of time domain lah. Okay, signal of audio signal with frequency of FM. Then you have FC, which is much higher than FM. Okay. Oh, sorry. Ni saya bentuk dia konsisten lah. Sorry lukisan tercantik. Okay. So, uh, let's say this one is maybe 3 volt, 3 volt. And this one maybe let's say 1.5. Smaller lah Not to the scale, sorry. And how we know it is having higher frequency? Because it have more complete cycle. Okay, nampak tak ni? For example, in terms of, let's say, in 3 seconds, for example, in 3 seconds, we have, for the audio is only half of the complete cycle. But for the carrier, we have a lot of completed cycle. So from this graphic alone, we can know that this one is FC. Okay. What happened for the AM? For it to be AM, the signal still maintained, and the shape is still maintained like this. But now it's modulated with carrier. So uh we will have carrier. Okay. 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 So this is the modulated. So the shape is the same, but it's like double. Okay, following the message, and we have carrier inside. Okay, the same as this. So that's why you see this one is your carrier frequency, and this one is the shape of your message signal. Okay, so this equation, if you see this one, remember just now we have the VAM signal, VAM equation is EC plus VM cos omega CT. So this equation is actually our envelope equation. This one. So this is envelope. So remember, sometimes we tell you, or they give it, the envelope equation is like this and that. So you know what is envelope? Envelope equation is only this one. Okay, if we want to take amplitude modulation, the entire. So logically, now we have V plus max and we have V plus mean. At the positive side of the axis, you have two value of max mean, and also at the negative side, you have value negative mean and max. Okay, and then you see this is your EM and this is your EM, and this one is V max, peak to peak. Okay, V max, peak to peak. V max, peak to peak. Okay, so V max, peak to peak. Okay, then you have another smaller one, V max, V mean, peak to peak. Only this small V mean, peak to peak. Okay, the rest pretty much straightforward. Okay, to calculate for the for the modulation index. Okay, based on this figure, you need V plus max minus V plus mean. So you're going to have this equals to 2em. Okay, 2em. V max. Okay, you're going to have 2em here. V max minus V mean. So you get this. Okay, and then V max. Sorry, V max minus V mean. This one. Minus V max V plus mean. This one. Okay. So the next is V max plus V min. Okay, V plus max plus V plus min. Okay, V max plus V plus max minus V min, V plus max and minus V min. V min kat sini, this one. Okay, and then after that divide by V max plus V min. Dia agak kejap maybe I use different slide. I create new slide first. Kejap. Dia confused sebab dia banyak. Okay, so I create new slide. Okay, okay. So we have this. We have this. Okay. So this is V plus because it at the positive side and it is a maximum. Okay. And then we have this one is V at the negative. Okay. Because it's at the negative side and it is a maximum. Okay. Okay. So this one is V minus max. Okay. V minus max. Max. So the maximum. And then at the positive side here, you have mean. Okay. You have the mean. So this is your mean. V plus mean. Okay. At the negative side, you also have mean. V negative mean. Okay. And then now you introduce to this concept of modulation index. Okay. Modulation index is actually equals to EM over EC, right? Is what we learned. Okay. So how we going to make for the EM? Okay. So if you see from this graph, okay, this is having 2 EM, okay? So EC is here, okay? So you have one EM here and you have another EM here. So that's why in order for you to have EM here, is actually V plus max, okay, minus V plus min. Later on, you will see is actually 2 divided by 2 becomes 1 lah, okay. V plus max minus V plus min. Mencabar nak mengajar pakai pakai apa? Pakai online punya benda ni. Okay. V plus max plus V plus min. Allah. Tukar kepada. Okay. So V plus min. Okay. And EC. Okay. EC ni, this one is later on you akan nampak sebenarnya dia dapat EM over EC lah. Sebab tu saya letak tepi. Okay. And so this is V plus minus V plus max minus V plus min. You ada 2 EM. Okay. Now the next is it will have two set of EC. Okay. Two set of EC. Tengok sini V max plus V plus min. Okay. So V max minus V min, V max plus minus V plus min, V max plus minus V plus min, you have 2 EM. Nampak tak sini? 2 EM plus EM. Over. Now V max plus V min pula. V max, V plus max plus V plus min. V plus max plus V plus min. Sekejap V plus max, this one. Plus V plus min. V plus min plus V plus max plus V plus min. V plus max minus V plus min. So you akan nampak dia akan menghasilkan ratio kepada EM over EC bila you expand them, okay? V max peak to peak, V max peak to peak, this one minus V min peak to peak, okay? You will only get this ratio, okay? So simple say is that whatever that you need, whatever that you have later, it must tail back to EM over EC. Kalau you nak senang, dia guna konsep trapezoidal ni. The concept of trapezoidal is even easier to see, okay? This one is actually look like a trapezoidal. Okay, look at concept of trapezoidal, where you have the width of the A, this one, over the width of the smaller one. So you will have A minus B and A plus B. So this is the concept of the trapezoidal. It's much easier. So V plus max minus V minus max over V plus mean over V. This one is your A and this one is your B. Okay. V plus max minus this one. Okay. So this is your A. Yeah. This one is actually the maximum of your amplitude. V plus max, V minus max. So this is your V plus max minus V minus max. Okay. And B is the smaller portion just now. This one. Minus V minus mean. Okay. The same goes for A. V plus max minus V minus max. Actually, this one is easier kalau kita buat latihan nanti. Okay, nanti saya akan tunjuk latihan lah untuk kita buat. Lagi senang. Sebab saya rasa macam sini nak terang sikit pun dia macam not really easy to see lah. Okay, saya akan tunjuk maybe I will give you I give you the sample of test. Maybe I will see later what kind of exercise I have. And then from there you akan nampak lah lagi senang. Sebab this one terlalu banyak. Saya sendiri pun kadang-kadang bukan confused. Sekejap. Tak nampak sangat V plus max semua ni. Tapi kalau you tengok latihan nanti you sebenarnya lagi senang nak buat. Okay. Dalam kelas saya actually saya utamakan latihan. Sebab tu you nampak dekat hujung ni awal-awal dah sorry. At chapter 1 tadi you nampak saya dah letak test 1 punya soalan lah. Cuma yang ni saya dah letak tak? Saya tak pasti. So I will be sharing to you the past test as well. So that we can go through together. But maybe I will share to you first and maybe you can try first. And then kalau you buat silap nanti kita belajar sama-sama lah. Okay. So this one is difficult to see. Okay. Difficult to see and the explain sometimes jadi macam apa? Kadang-kadang tersilap-silap. So ada V plus max ni. Jadi sebab tu saya tadi pun macam ada terganggu sikit sebab terlalu banyak notation minus and max ni. Okay. Tapi hujungnya sebenarnya jawapannya semua akan sama dengan EM over AC tu je. Sebab dia terlalu banyak lah. Benda dia tunjuk tu. Okay, M could be obtained from the amplitude of sideband and carrier signal. So M is also a ratio lah of a sideband amplitude. Ingat tak sideband amplitude tadi? Sebenarnya dia ialah M EC over 2. Okay. So over carrier amplitude. Carrier amplitude EC lah. Over EC. Ujungnya you dapatlah M over 2. Okay. So M over 2 is from a ratio of this from a ratio of sideband or over carrier you get the value of modulation index. Okay. So kita akan sambung semula pukul 2. Okay. This one better solve using exercise. Okay, nak explain pun dia agak susah sikit sebab dia terlalu banyak notation. Okay, macam EMT lah, lebih mudah kalau kita buat latihan daripada nak terang-terang tu, dia terlalu banyak nak terang. Line charge, surface charge, volume charge, electrostatic and so on lah.